This is the second part of our lecture. In this lecture, we will study about BCNF. Then we have BCNF, Boyce-Codd normal form. Boyce-Codd normal form does not allow dependencies between attributes that belong to a candidate. It is somehow similar to the transitive dependency or the 3NF, and we also call this form as 3.5 NF. So now we will discuss the differences between BCNF and 3NF in coming slides. So here we check the dependencies of attributes that are belonging to a candidate key, the interdependencies between the attributes. BCNF is a refinement of third normal form in which it drops the restriction of a non-key attribute from the third normal form. Third normal form and BCNF are not same if following conditions are true. The first one is the table has two or more candidate keys. Second, at least two of the candidate keys are composed of more than one attributes. And the third thing is the keys are not disjoint. That is, the composite keys share some attributes. So these are the main thing about BCNF. Decomposition or loss of information. If decomposition does not cause any loss of information, then it is called lossless decomposition. It is possible that we may lose some data or some information in the database due to decomposition. So if there is no loss, then it is called lossless decomposition. If decomposition does not cause any dependencies to be lost, then it is called dependency preserving decomposition. Second thing is, if we decompose a table into multiple tables and the dependencies still exist in the new tables, then that decomposition is called dependency preserving decomposition. Any table scheme can be decomposed in a lossless way into a collection of smaller schemas that are in BCNF form. However, the dependency preservation is not guaranteed. Actually, when we decompose a table due to BCNF, then the collection of data or the information will be lossless. There will be no loss of information, but the dependencies may be lost. So the dependency preservation is not guaranteed in BCNF. We may lose some dependencies among the attributes when we decompose a table due to BCNF. Any table can be decomposed in a lossless way into third normal form that also preserve the dependencies. So in third normal form, it is possible. 3NF may be better than BCNF in some cases. Actually, in most of the cases, when we design and develop our databases, we normalize our database up to 3NF because 3NF is usually considered as sufficient to be accepted or to be implemented in the databases to get the quality of data. Here we have a table having 6 attributes, and in this table we have some composite key and some sort of associations among these attributes. So we are going to decompose this table or relation according to BCNF. Here in this relation, we have a composite key referred as key 1. It is the combination of A1, A2, and A4. This key 1 is determining A5 and A6. So here we have these three attributes, A1, A3, and A4. They have a composite, and this composite is determining A6 and A5. There is another composite, that is A3 and A4. This is key number 2. These are actually candidate keys, key 1 and key 2, both are candidate. So key number 2 is determining the attribute 5 and attribute 6. A5 and A6 both are dependent on key 1 and key 2. There is another attribute, another functional dependency, that is A3 is dependent on A1. So we are going to split this table into 3 different tables to remove the interdependencies among these attributes. So the first is quite simple. A1 determines A3. So we are taking these 2 attributes and make a new table. So here we have A1 and A3. After that, we take A1 and A2 with A4, this composite, and create another table for it. For the remaining, we take the composite A3 and A4 along with their dependents A5 and A6. So we will have A3, A4, A5 and A6. Now we can connect these tables by using their primary keys and foreign keys. So these tables can be connected with the help of A1, and these 2 tables can be connected with the help of A4. Similarly, A3 can be used to connect with this table in this way. Here we have an example. This table is not in BCNF. We have city, street, and zip code. The first key is city plus street. This is a composite. The second key is zip code plus street, a composite of 2. And here we have no non-key attribute. So this is in third normal form. The composite of city and street determine the zip code. The zip code itself determine the city. So there is some sort of dependency between attributes belonging to a key. So how will we convert this into a new scheme? Actually, we will have multiple tables for this. So this is the old scheme. What we do, we take zip code and street. This is also a composite key. So, and make a new scheme for this, and then we take city with street and create a new table. When we create these 2 tables, we will have a loss of relation that would be from zip code to city. We can also create new schemes alternatively in this way. So what we do, place the 2 candidate primary keys in a separate entities. We take the candidate keys from this table and provide separate tables or separate entities for each candidate key and make them as primary key. Place each of the remaining data item in one of the resulting entities. according to the dependency of the primary key. And then we put the remaining data to the new tables according to their dependencies. It's quite simple. First, check for candidate keys in the table. Then take the candidate keys and create new tables for each candidate key and make them primary key. And after that, take the remaining attributes and put those attributes according to their dependencies along with their candidate keys in the new tables. This is another example. Here we have movie title, studio ID, movie ID, author name, role, and payment. Here in this table we have some keys. The first one is the composite of movie title, studio ID, and actor name. The second candidate key is the composite of movie ID and actor name. So these keys are determining the rest of the attributes, and there is one additional functional dependency, that is the movie ID is determining the movie title. So according to these, the BCNF is violated, so we need to split this table into some new tables to remove the interdependencies among these tables, and for each candidate key we will create a new table. So here what we are going to do, we are making two tables. So in the first table, movie ID and actor name is taken. This one key is taken, and the dependents for this key are taken. So here we got role and payment, and also we got the movie ID and actor name. For second table, we are going to take the second key. Actually this one is key 1, so we are going to key 1 for second table, and here we will have movie title, studio ID, and actor name. So all these attributes are covered either by the keys which are made primary key or the attributes attached with these keys in new scheme. So here we are losing one relation, that is movie ID determination to movie title in these two tables. So we can create some additional schemes too, that is we can give the movie ID and movie title a separate table. So with the help of this table we will get this relationship back, so the relationship is preserved. In example number 3, we have a table having 3 attributes: client, problem, and consultant. In this table we have some keys. The first key is the composite of client and problem, and the second key is the composite of client and consultant. So here we have no non-key attribute, no transitive dependency, so this table is in third normal form. The client plus problem, this key is determining the consultant, and the second key, client plus consultant, is determining the problem. So there is dependency between the attributes belonging to non-key, and this is a sort of violation for BCNF. There should not be any interdependencies towards the composite keys. So here we are going to make some new tables. This one is the old table according to this, and according to these keys we will create some new tables. So key 1, here we have client and consultant, we got it. Then for key 2 we are going to get the client and problem. and here we have a loss, that is the relationship between consultant and problem, and we can also create one additional table, that is consultant and problem. Now the difference between BCNF and 3NF. In most of the cases, we process our database till the third normal form, and usually we don't consider BCNF. Third normal form is considered as sufficient for the normalization of a database. However, for optimization or for better performance of a database, we can go further. So first we have the concept. In third normal form, non-prime attributes must be transitively dependent on the candidate key. So there must be no transitive dependency among the attributes. In BCNS, any trivial dependency and relation, say X determines Y, X should be a super key of the relation. Actually, in BCNF, we look into interdependencies among the table. If one attribute is dependent on multiple candidate keys, then we must split that. Then dependency 3NF can be obtained without sacrificing any dependencies. And we checked that with BCNF, we may lose some dependencies among the attributes. In process of decomposition, this is the 3NF is lossless decomposition, and with 3NF we will not lose any sort of information, while in case of BNS we may lose some information in most of the cases, and particularly we may lose dependencies among the attributes in case of BCNF. This is the summary of our today's lecture. Actually, we studied the first normal form and second normal form in our previous lecture, but in this lecture we just revised these two forms in the beginning. So in first normal form, we checked for atomic value or the multi-value attributes, and we ensured that there is no repeating groups or no multi-value attributes in a table. A second normal form, we checked for the partial dependencies. If there is a composite key and all the attributes are fully dependent on the composite key, full composite key means that there is no such attribute which is dependent on a part of that key, then that case is in second normal form. In second normal form, we usually split the composite key. Depending upon the situation, if there is partial dependency, then we split that composite key and make some new tables according to that key. In third normal form, we check for the transitive dependency. If attribute A is determining B, the attribute B is determining C, then we can say that A is also determining the attribute C. So we must remove this transitive dependency. We must create two or more tables so that there would be no transitive dependencies among the attributes. In BCNF, the determinants are candidate keys. Means that if an attribute is dependent on multiple candidate keys, then we must remove that dependency and split these attributes into multiple new tables. So all the candidate keys must determine the attributes that are present in the table, and if there is an attribute that is dependent on another candidate key or two or more candidate keys that will be separated. So in today's lecture, we reviewed the previous lecture, then third normal form, Boyce-Codd normal form, and in third normal form we studied about the transitive dependency, and third normal form, the decomposition process of third normal form, and the problems resolved in third normal form. We checked the second normal form for these problems. And BCNF, we checked the rules, the decomposition, the loss of information. There were two types, the lossless information and the relationship preservation. And at the end, we studied about the differences between BCNF and 3NF. This was all about 3NF and BCNF. I hope you will also explore this topic by yourselves. If you have any question, you can put your comments in the KCMS. Thank you.